Okay, so which of the following diagrams addition of two vectors 8 Newton and 6 Newton? Which of the following diagrams additions of two vectors 8 Newton and 6 Newton? Okay, quickly drop the answers in the chat box. So this question is very easy. The diagram is not a bit clear, but here this arrow is pointing downwards, this one upward, this is upward and downward, and this is upward, and this is to upward, and this is to the left. So we need the addition of two vectors, 8 Newton and 6 Newton. Okay, I got two answers from Hiroshan Safar. Abhishani. Yeah, we will discuss about it at the end of the class. Okay, so the answer here so here this one is 8 Newton and this is 6 Newton, and the resultant this is 10 Newton. I think so there is some typing errors. I think this is scanned from pace rule. So pace rule sometimes, I mean most of the time have some typing mistakes. I hope you are okay. So here this is 8 Newton and this is 6 Newton, so the resultant is 10 Newton. Yeah, pointing upward. Okay, so the answer is the third one. Okay, question number 2. Which of the following sets of forces never produces a zero resultant? Okay. Drop your answers in the chat box. Which of the following set of forces never produces a zero resultant? Okay. Don't take much time. I need each of you to drop your answers in the chat box. Text your answers to TKI. Jafar, you should text to the other admin TKI. It will be easy for me to be on the desktop. What about Adiyushani and Aisha? Okay, so here the theory is if an object in equilibrium under three forces. So here we have all, each of the options are three forces, 1, 2, 3, 1, 2, 3. So each of the options have only three forces. So in equilibrium lesson, under force equilibrium lesson, we studied if an object is in equilibrium, then we can construct a triangle. Okay. So if an object is equilibrium under three forces, then we can construct a triangle. Okay. So therefore, we know the magnitude are proportional to the length. In geometric representation of a vector, the magnitude are proportional to the length of the line segment. Okay, so then we can consider this proportion with length. So 5, 5, 5 means, so 5 meter, 5 meter, 5 meter, for example, 5 centimeter or 5 millimeter line. So this is 5 millimeter, and this 5 millimeter, we can construct a triangle. So it's actually an equilateral triangle. So therefore, we can construct a triangle. Therefore, this will be in equilibrium. So this can produce a zero result. So this one, 5, 5, and 10. Okay, and apart from that, when we have a triangle, let's say a length A, B, C. So if we take a triangle of length A, B, C, then give me a second. Adam, I'll hit you if you. Okay, so if we take a triangle, let's say lengths are ABC. So here we can state this inequality. The length of A is always greater than, sorry, less than or equal to the sum of other two sides. So less than or equal to B plus C. Or if we take B, the length of B is less than or equal to A plus C. Or C is less than or equal to A plus B. If you take the side of a length of a side of a triangle, that length will be less than the sum of other two sides. Okay, this is true for all triangles. You can consider any triangle. This will be true. Triangle means there will be three sides, so each side satisfies this equation. The equal condition is where you can think A is it is equal to B plus C when the area becomes zero. So then in that case, the length A is equals to B plus C. So this length is B and this C. So A equals B plus C only when the area of the triangle is zero. Okay, vice versa. That means B, to consider the length B as A plus C. That means B will be the longer side and this is B, A, C. So in that case, we can consider like that. So therefore, you should always remember this. So in this type of question, you can write. Now here, if I take 5 plus 5, it is equals to 10. That means here two forces are acting on an object. So 5 Newton, 5 Newton. So therefore, it's now this the other one is 10 Newton. So then again, resultant will be 0, right? Overall resultant will be 0. So for that, you have to remember this thing only. So if you know this, then you can argue with this. Okay. So here 5, this is greater than, less than sum of these two. And then this is 10 is less than 5 plus 10, 15. And this 10 is less than 15. Okay. So here this 10 is less than 30. And this 10 is less than 10 plus 20, 30. And 20 is less than, 20 is equal to 10. So that is equal condition where the two forces, all the forces are parallel. When we say the is equal, then for example here if you consider this 20, 10 plus 10 is 20. So that means both 10 newtons are acting in one direction and 20 is opposite direction. So three forces are parallel, so we can get here also 0. Now here if you take this 5, 5 is less than 10 plus 20. So 5 is less than 30. Okay. And if you take 10, 10 is less than 25. That is okay. But if you take 20, it is not less than 5 plus 10, 15. It is not less than 15. Therefore, this one cannot produce zero result. Okay. Did you all understand? If there's any question, please let me know. Zufar, I hope you can remember we discussed this in our last class, right? Last Sunday. That we studied in vectors. Now we are doing this question in force equilibrium. So that's why I told you vectors are the most important lesson. I mean, now, as I told you, the mechanics is the most important chapter in your syllabus. There are 11 units. Out of that, most important one is mechanics. So if you ask me what is the most important chapter in mechanics, I would say uh, it is vectors. Okay. So if you understand the concept and everything vectors very well, then everything will be much easier. All right. Okay. So third question. A child of weight W hangs at rest from the ends of a light inextensible rope as shown in the figure. If the weight of the spring balance S uh, is negligible, the reading on its scale is okay. I got an answer. What about the others? Okay, I got two answers. Both seem to be the same. Who has got an answer? Okay. So here we studied that the, the scale reading. The scale reading is nothing but the tension in this hook. The tension in the hook is the scale reading. Okay. So all we need to find is the tension acting on the hook of this spring. So the spring is massless. So therefore, let's say here is the tension acting here is, let's say, T. So the hand, due to the weight, the the boy is attracted downwards. So therefore, the hands are pulling the string down. So since it is a light inextensible string and it goes over smoothly, so the tension will be same both sides. Tension will be same both sides. So we can write the force acting on the boy. So we can consider the force equilibrium of this ball or whatever. So in upward we have T. So this I have now the tension acting on the spring. So equal and opposite tension acting on the hand plus P. Here also hand plus P is equals to the weight W. So therefore P equals W divided by 2. So therefore answer is the third one. Yes, here our answer should be T. That is the scale reading W over 2. Okay, question number 4. The diagram shows a uniform rod resting horizontally on two supports X and Y. The length PQ and uh, resting horizontally on two support X and Y. The length PQ, QR, RS, SP are equal as Y moves from S to P, keeping XZ stationary. The reaction on the rod due to X. Okay, so I think there is something. The diagram shows uniform rod resting horizontally on two supports X and Y. The length PQ, QR are equal. As Y moves from S to P, keeping XZ stationary. Okay, I think there is something else. Okay, I think we only keeping X stationary. There is no Z. Okay. So here no X, Z should not be there. So keeping X stationary. Okay. The reaction on the rod due to X. So you want to find this reaction, let's say R1, and here the reaction is R2. So what would happen uh, to R1 if we change the Y as Y move from X to P? Okay, so what would happen to R1 as Y decreases and that due to Y increases and that due to Y decreases. increases and the due to y also increase remains equal to the due to y. What is the answer? Okay, I got an answer and it is correct. Okay. Okay. So I got answers from everyone. Abhi Shani, what is the answer? Didn't get a response from you. Abhi Shani, can you hear me? Okay. So my intuition, the answer is 3. Increases and that due to y increases. Now, if you consider this position, okay, or else when y is here, okay, when y is here, so both x and y has to bear the weight. Okay, so that means we can think the r is now since this is uniform, it's all uniform. Okay, so the mass distribution is uniform, weight distribution is uniform. So therefore, we can think when y is at the other end, so the R1 and here R2 equally divide the weights. That means here will be W over 2 and W over 2 when y is here. Okay. But when we decrease the y to here, so this addition, this mass actually completely should bear by y. Okay. Then now here in this part, the weight is less. So therefore the weight should bear had to carry by R1. This will be less than when this is at here. So therefore increases and that due to y also increases. So that I can show you analytically. Let's take display like this. So here, let's say this total length of this is, let's say, total length we'll consider as L. Okay, and this length I'll take x to y. The length is simple x, and therefore this length will be L minus x. Okay, so first we can consider the vertical equilibrium of this rod. So therefore I can write R1 plus R2 equals, let's say the weight of this entire rod is W. Entire weight is W from the center of gravity. Okay, so R1 plus R2 equals W is equation 1. And then I'll take the moment from point X. From here, I'll take the moment, clockwise moment. So we have W into this length is L over 2 minus, here the length is, this one is R2 times X. The length is perpendicular length is X. So this is equals to 0 because it's in equilibrium. So net torque has to be 0. Right? So then we can write R2x equals to R2x equals WL over 2. Okay. R2 equals W times L over 2. And then yeah, right, R2 equals WL over 2x. So then we can write R1 plus R2 is equals W. So R2 I can substitute R1 plus WL over 2x equals W. So R1 equals W minus WL over 2x. Okay. So then we can see uh, if this term increases means R1 will decrease. If this is increase means R1 will decrease. Okay. So what happens if you increase x? If we increase x, this term will decrease. So reduction, it's a minus. So the reduction is decreasing means R1 will increase. Okay. Or you can think the other way around. Okay. If you decrease x, so the division is become you are now first you are dividing by 10, but now dividing by 2. Right? If you decrease this, then this term will increase. If the term increases means you're subtracting with a larger term, so R1 will decrease. So if you decrease x, R1 will decrease. If you increase x, R1 will increase. Okay, is that clear? Okay. By the way, to answer to this question, no need to do all this calculation. But the current applying to now, what you can do is, so if this is here, then since the rod has uniform, since the rod is uniform, the weight distribution will be uniform. Therefore, both the rods at X and Y has to both X and Y has to bear the same weight. The weight will be equally distributed, WO to WO. But now when we consider only when Y is here, only this much mass is equally distributed. Okay, so we can divide by here. So then this will be here, and this one completely should bear by Y actually. Okay, so therefore when you decrease Y, decrease here from here to here, then here the reaction also decreases. So if you increase this, here the reaction will increase. So therefore answer is third one. Increases, that due to Y also increases. Now you might have this practical experience now when you try to let's say you and your friend moving a large table or large huge box. When you carry that, so you can feel in such occasions what would happen if the both of you carrying at this same position. Okay, then both will feel the same weight. Okay, but instead your friend is here. If you move to somewhere here, then you feel more weight than your friend. Okay, you can do this. You can do small things, practical, and see if you haven't done. By the way, I have experienced this many times in carrying long tables and woods and ladders and also coffin. Yeah. So anyway, I hope you all clear with this, and let's move on to question number 5. Okay. Two spring scales of negligible mass are connected together and a 10 kilogram is hung as shown in the figure. Okay. Two spring scales of negligible mass are connected together and 10 kilogram mass is hung as shown in the figure. Which of the following statement is true? Okay, I got one answer and it's correct. Very good. Okay, Zufar also correct. Dushan correct. Aisha correct. Hirosh correct. Yes. Each scale will read 10 kilogram. Okay. So each scale will read 10 kilogram. Suppose each scale is, let's say, 1 kilogram. 1 kilogram, and this is weight also 1 kilogram. And let's say the hooks are connected at the down. The scale connected the hooks are down. So then now if we consider this one reads, it has to be a weight of 10 kilograms. So it will show 10 kilogram, but this one will show 10 plus, and then it has to carry this weight mass also 11 kilogram. If both have 1 kilogram mass, so this scale has to carry only this mass. So it will show 10 kilogram, but this scale has to carry this 10 kilogram as well as this 1 kilogram. So it will show 11 kilogram. Okay. Question number 6. Okay, I got an answer, but it is, let's check. Mm, Not correct. Mm, Rosh, not correct. Aisha, correct. Okay, here the answer is 1. All A, B, C are false. Okay. A system of coplanar forces acts on a rigid body. If the resultant of moments of the forces about a certain point, they are not saying any point, it's saying about a certain point, and the body is 0. Consider the following statements. The resultant of the movement of forces about any other point of the body is always zero. So this is wrong because now here it says about a certain point. If that certain point acts on the resultant, so let's say this is the resultant of the system of coplanar forces, and that certain point is somewhere here. Okay, let's say that certain point is here, then movement is zero. Movement is zero. But if we take any other point, there is non-zero movement will be there. So it says the resultant of the movements of force about any other point on the body is always zero. That is wrong. So A is wrong. Raise your hand if you all understand the statement, explanation about the statement A. Raise your hand if you understood the explanation regarding the statement A. I see only one hand raised. What about the others? Didn't understand? Super, okay. Good. About Hirosh and Abhushan? Okay, good. Hirosh? Hirosh, did you understand? Hirosh, are you there? Can you hear me? Hirosh? Okay. Uh, I asked whether did you understand the state explanation regarding the statement A. If you understood, then raise your hand. If not, so you didn't understand, no? Then okay, I'll explain again. So here it says a system of coplanar forces. There can be two forces, three or five, any number of forces acts on a rigid body. Okay, if the resultant of movements of the forces about a certain point on the body is zero, consider the following statements. Okay, the resultant of movements of forces about any other point on the body is always zero. So now here it says about a certain point. Okay, the moment is zero. About a certain point, the moment is zero. Okay. If the moment is zero about a certain point, doesn't mean it's in equilibrium because that certain point could be somewhere on the line of action of the resultant. If that certain point is on the line of action of the resultant, then moment is zero. But if you take any other point, the moment is not zero. Okay, so therefore, to have zero resultant, the moment has to be zero from elsewhere, anywhere. Okay, so therefore, the statement A is wrong. Okay, because this certain point could be a point on the line of the resultant. Okay, so therefore, we can't say that the moment from other point will be zero, right? Did you understand? If this is the resultant and that certain point is somewhere on the line of action of the resultant, then movement will be zero. But if you take from any other point, there will be non-zero movement. Okay. Hirosh, did you understand? So statement A is yeah. Only for the force purpose, the moment is same anywhere from any point. If an object is in equilibrium, the resultant moment will be zero from any point. Okay. But here there could be a resultant, and there might be taking the moment from the point from a point on the line of action of the result. Then it will show zero moment, but we can't ensure that this is in equilibrium. Okay. So therefore, statement A is wrong. The body must be in equilibrium. Okay, so the system coherent force result a movement of force about a certain point. Now here, if there is a resultant and then you are taking the moment from that certain point, so we can't say the result. We can't say it's in equilibrium because it will be as a resultant. Okay? So therefore, B also wrong. The body must be in equilibrium. See, the resultant force acting on the body must be zero. We can't say that. That's why we can't say this also. Okay. So therefore, all A, B, C are false. Correct one is statement. All A, B, C are false. So question number 7. A man of weight 500 newtons standing on a platform P supported by two light springs passing over two light smooth pulleys A and B. Supports himself by pulling the spring as shown in the figure. If the weight of the platform is 1000 Newton, the force exerted by the man on the spring should keep the platform uh, balanced, to keep the platform equilibrium or balanced, to keep the platform equilibrium. I think your answer is correct. Because I have a couple of years back of memory for this question, that was the answer. It was not certain, but have some the memory of it. Good. Okay. So here first we can mark the forces. Okay. So weight of this vertically downward 1000 Newton, and here the tension we mark E1. So here this one also E1. and here also the tension P1, and then the man's normal reaction force acts on this platform. So the man's weight is 500, so this one is 500. And let's mark this tension T2. Here also T2. So here also T2. So the force acting vertically upward on man's hand also T2 by the string. Okay, so first we can consider the vertical equilibrium of the platform. So then we have vertically upward T1 plus T2, and then downward we have 1000 Newton minus 500 Newton equals 0. Okay, so then we get T1 plus T2 equals 1500 Newton. So that is obvious. So these two forces has to carry this weight. T1 plus T2 equals 1500 Newton. And then we can consider the force equilibrium of the ball. So then we can consider what is the vertical upward force T2 on acting. Okay, T2 is vertically upward, and then normal reaction force here, normal reaction force. So that normal reaction force is equals to okay, so here I can't say this is 500 straight away because okay, so to okay, so wait, hold on, I will do this question. So here the normal reaction force, I'll take mark R, and then here the normal reaction force R, and this here E2. Okay, so here what I'm going to do is I consider this system, okay, and consider the force equilibrium. Okay, so I consider this entire system, which I have marked in this square. So then what we have vertically upward, we have this T1 and T1. We also force T1, these two T1 plus T1 is equals to the total downward force. The R is the internal force pair. So T2 also internal force pairs to this system. So only the weights are vertically downward. So 1000 plus 500. So therefore 2T1 equals to 1500. So therefore T1 equals 750 Newton. Okay, then the force exerted by the man on the spring to keep the platform balanced. So then we can consider the force equilibrium of the man. Yeah. So then here we want to find this T2, the force exerted on the string. Okay. So then what we can do is we can consider the force balance of this man. So I consider the man and apply force vertically upward. So what are the forces acting on the man? So the man pushes the string downward, therefore string pushes the man upward, T2. And here the normal reaction force plus R is equals to the weight of the boy, which is 500. Okay. So T2 plus R equals 500. And then we can consider the force equilibrium of this platform, which is P1 plus P2. So those are the upward forces, is equals to 1000, the weight of the plant, plus the normal reaction force R. So here the R I can substitute 500 minus P2. So here P1 is 750 plus P2 is equal to 1000 plus R is 500 minus P2. Okay. So then we take this P2 to the other side, it becomes 2P2 is equals 1500 minus 750. So therefore T2 is equals to 750 divided by 2. So T2 equals 375 Newton. So the answer is 5 volts. Okay, I'll do this question one more time. Okay. Okay, so here I consider first we can consider this system. Then we have T1 plus 2T1 equals 1000 plus 500, 1500. So therefore T1 equals 715. So the second one, so secondly, I consider this frame of reference. Okay. I mean this system. So if I consider this system, so the boy and the plant again. So then what are the forces acting there? Vertically upward P1, okay, and here vertically upward P2, and here also vertically upward P2 plus P2, and okay, and then here downward forces are the weight of the boy downward by 100 plus this 1000 weight of this. Okay. So then T1 is actually 750 equals to T2 equals 1500. So therefore T2 is equals to, taking this to the other side, subtract 1500, 750 is 750 divided by 2 is equals 375 Newton. So this way is good because otherwise I have to do three equations. Right? Okay. So here first I can consider this system. Okay. So then I can get 2T1 is equals to 1000 plus 500, 750. Okay. And then after that I consider this system. Okay. So if I consider that system, the vertically upward force, this tension is there, and here the tension is there, here also tension. So T1 plus T2 plus T2. And the external forces to this system is the weight of the platform downward 1000 and weight of the man downward 500, 1500. Okay. So In this way, we can get the answer quick. Okay. See, actually, we need practice, right? Now, first time when I did this, I had to use three equations to solve. And with that knowledge, when we are doing with questions, then we get some ideas. Okay. So therefore, it's very, very important to do more and more questions. I think this is the sentence that the frequent sentence that I'm using. You have to do more and more questions. Okay, fine, whatever. All right. I hope you are clear with this so that we can move to the next question. Okay. Which of the following group of forces acting on a body cannot have a zero resultant force? So this is very similar to what we discussed earlier. So you can see if you do past papers. Now, whoever did this 2000, the 1994 past paper. Okay. So let's say someone in 1995, that the year 1995, someone when doing the 1995 facing the exam, if that person have done past papers of 1994, then he can answer to this question. He might have already practiced to this question. So you understand? So it's really important to do more and more questions. All right. So what is the answer? I got one answer from Hirosh, correct. Expect everyone should put your answers and everyone should be correct. Okay, you are correct. Okay, good. Abhishan. So here the answer is the fifth one because we can see the 4 is not smaller than 1 plus 2. So 4 isn't 1 plus 2, so this is not correct. So therefore, this one cannot be in equilibrium. Others can. Now here if you take this 4 is less than 2 plus 3, 5. So 4 is less than 5, so therefore it will be in equilibrium. I can't turn to this side. Since morning I'm having a neck pain. It's really painful. If you guys know any solution, let me know. The diagram shows two boys pulling a bucket of water from a well. Which of the following graph correctly represent the variation of the tension T in spring with the angle theta? Okay. If you have such experience, you may know already the answer. What do you mean by Salonpas? I have no idea. What is it? Is it any cream? Okay, I will try that. Thank you. So here the theta, I think, measured the angle between the vertical and the string. But I'm not getting any answers. Why is that? Okay. Erosh, might be correct. Okay, so that is, I mean, you may have experience in such occasions. Okay, so here I think the answer is so here not sure. So the answer is either first one or 15. But what is the difference between first one and 15? So this is like more like going to 0, but it has a intersection. When the angle is 0 means. So angle 0 means this wire length will be, this will be more down, so the more deep. Okay. So now it's, if you have practice, I mean practical, I mean experience, then you might know when the angle is like that, it's easy to pull, but it will be very difficult to make the angle, I mean 90 degrees, I mean horizontal. You need to apply larger force. So when, like for example, no need to have this such bucket and all. For example, let's say for example, you want to tie up a rope to hang clothes. Okay, so if it's making a bending, it is easy to, you don't need much force. But if you want to make it horizontal, you need to give a large force, no, right? Even your mothers might know, like when you tie up a rope to hang clothes, if you need a larger, you need to apply larger force to make it horizontal, right? So the force required will be enormous when this angle reach to 90 degrees. When it comes to 90 degree, you have to apply a larger force. Okay, so the answer is either first one or fifth one, but let's see. I'll get you a correct answer. Or else you can, I mean, you can consider the force equilibrium. So here the, let's say weight W. So here T cos theta, both components will come. Here the weight, let's say W. And you can resolve this tension into two components. This one will be T sine theta, and this one also you can resolve T sine theta. And here this component T cos theta and 2T cos theta will come. So vertically upward we have T cos theta plus T cos theta is equals to W. So 2T cos theta equals W. So therefore T equals W over 2 cos theta. So we can see if theta is increasing. If theta increases, what happens to cos theta? Cos theta will be decreases. It will reach closer to 0. Right? When you divide by very small number, this entire number will be very big. Now, for example, let's say W is 10 Newton, okay, and 2 into, let's say you are taking small angle, like, sorry, if the angle is very close to 90 degrees, it's reached to, if theta goes to 5 over to 90, cos theta goes to 0. So when it become closer to 0, or else the angle is closer to 90 degrees. So you are dividing by, let's say, 0.001. Okay. Then 10 divided by this will be 10,000. So it will be 10,000. So even if you get angle is even closer, that means that this number will be now, let's say this is 0.001. So now the value is be 100,000 newtons. So you can see as the angle approach to 0, this value will approach to infinity. So therefore, you need a larger force. Okay. But when this angle is, let's say, 0, okay, first theta is 0 means, theta equals 0 means, theta equals 0, it will be 1. So T equals to W over 2. There will be a finite value. So the answer has to be 51. Okay. So therefore the answer should be, now even for this also you can get some value, but it's like close to 0. But comparatively this one will give an idea of intersection might be there. So therefore the answer should be 15. Okay. Okay, do question number 10. Here the typing mistake I can see. This here is not F1. This F1 should be here. The force F shown in the figure can be obtained by adding the forces F1 and F2. Okay, this is an easy question, very easy. Put the answers in the chat box. Yeah, Aisha, yeah, correct. Zufar, correct. Okay, so the answer here is Hirosh, correct. So answer here is 1, all ABC. So the resultant of these two somewhere in between here. So this one you can consider the triangle law, it will be this way. So the resultant of these also will be like this. So therefore all ABC are correct. All ABC can produce the result, this result. Okay. We do 11th question. Okay. A light string passing over smoothly carries a spring, balance of mass 1 kilogram, and two weights mass 1 kilogram, 2 kilogram, as shown in the figure. The reading on the balance will be. Okay. So some students may question vector command. They will put the F equals ma and try to find the acceleration and all. But the first thing you have to understand is system is in equilibrium, because this side total mass 2 kilogram, this side total mass 2 kilogram. So the problem will be easy. Right? So if you didn't realize that in that means in such question, then you will be in trouble, because you will waste the time, in vain time, because you take time to write the equation and find the acceleration for all these for nothing, because it is not accelerating. Okay, so therefore you can consider the force equilibrium simply. So here the tension will be equal to the weight of this. So everything, so we can go with the mass also. So here 2 kilogram is the tension, 2 kilograms, so multiplied by G. So here also 2, okay. So here it's pulling downward with 1. Okay, so you can consider the force equilibrium of this spring. Okay, its weight downward 1 kilogram. That one should multiply into G, get the weight. Okay, so I'll write just omit the unit kilogram and I'll write 1 into G. And in this one pulling downward 1 kilogram into G, so 1 into G. This one pulling upward with the force tension through G, 2 kilogram into G. So therefore we can consider the force equilibrium. So actually you want to find this tension. So that is actually 1 kilogram. That's right. No need to consider anything. So here the tension will be equal to this mass, 1 kilogram. So the reading is 1 kilogram. So simply this 1 kilogram will be here the reading. Answer is 2. Okay. Okay. Figure shows 4 coplanar forces. Coplanar means all 4 forces are lies on the same plane. A, B, C, D. A, B, C, D drawn to the scale. Okay, drawn to the scale. So therefore, this means these forces are drawn according to the precise geometric representation. Acting on a point object O, the resultant force are acting on O will most likely to be along the direction. Okay. Okay. So we'll try to get the uh, resultant. So here what I can do is check. So I take a parallel line, draw a parallel line from here. I draw a parallel line for this from this point. So these two intersect at this point. So therefore their resultant will be this here to here. So this is the resultant of these two. That means instead of B and C, now I can remove these two. Okay, now I have only this. Instead of B and C, I have this. And then I can draw the D. I can draw a parallel line for the D. So Okay. So this one I take on here. So then, hold on. So I have to draw a parallel line to be from here. And then now I draw the resultant of these two. So it will be here. Okay. So therefore instead of now these B, C, D, I have this only blue vector. So then that is longer than A. Therefore the resultant will be along this side. Third one is the answer. C, 2, 4, 4. So here the answer is third one. So in exam, remember if they have said drawn to the scale, then you can take your pencil and ruler and draw in the question paper itself. Okay. So you have to do this construction in your exam paper. Okay. So the resultant will be this direction. Third one is the answer. Okay, so 13th one, it's easy. It's a typical force equilibrium question. The object is equilibrium under the influence of three forces. By the way, here again, there's a mistake. This line should be here. From here to here, it should be like this. That string should be like this. Okay. Next, because all three forces should intersect. No? This is the line of this. They will intersect. Because if an object is equilibrium under three forces, then all three forces are uh, concurrent. That means they all goes through a common point. An object of mass m is hung by a spring and is kept in equilibrium as shown in the diagram by horizontal force. The magnitude of F is. Okay, I know, I already got the answer. If you got the answer means you can share the chat box, please. Okay, I'll do this. So here we can consider the force equilibrium. Okay, so we can consider first I'll resolve this tension into two perpendicular components. So the vertical this one, this one. So if this angle is theta, this angle also theta. So towards the angle cos, this is P cos theta, this is P sin theta. So I can consider the vertical force equilibrium. So we get P cos theta equals mg, which is equation 1. And then horizontal force equilibrium, P sin theta equals F is equals to, so I take 2 divided by 1. So F over mg equals F divided by mg equals sin theta divided by cos theta. Sin theta divided by cos theta. So F equals mg tan theta. Okay. So therefore, you should write this in your note also. Okay. In your theory book also, if you can write, it will be good, because keep in mind, if in such case, F equals mg tan theta. Okay. So the answer is the first one. You can copy this to your theory notebook also. A triangle of recursion. Okay, so here we can do another method also there. So here not the triangle of recursion. Here we can consider the force equilibrium. If it's equilibrium, we know it will be, we can construct a triangle. Okay. For object is equilibrium, we can construct a triangle. So first I have the force to the right, okay, and then tension in this direction, and weight vertically downward. Okay. So here, so this angle is 90. This is F, and this is tension. This is mg. Okay, and this angle is theta, and therefore this angle will be 90 minus theta. Okay, so then we can use Lami's theorem. So F over the opposite angle is is okay, hold on. I will just quickly recap Lami's theorem here. This is this. Okay. So here I can use Lami's theorem. I will explain you that. Okay. So here I will write down. So if I'm correct, here F over F opposite angle theta, F over sin theta equals to T over 90 sin 90 is equals to mg over sin 90 minus theta. Okay. So then we want to take F, so we can consider this and this. Okay. So here from this is 1 and this is 2. So from 1 I can write F over sin theta equals P over sin 90 is 1. To take the sin theta to that side, F equals P sin theta. So from 2 I can write mg over Sine 90 minus theta cos theta. No, I take this as the second. Okay. T over sine 90 and G over okay. So from this, from second relation, f over sine theta equals mg over cos theta. So therefore, f equals sine theta take to the other side. So sine theta divided by cos theta will be mg tan theta. No need this first relation also. From this, straight away we get f equals mg tan theta. But I hope you all can remember that that day and last week when we did the force equilibrium, the Lamis theorem I couldn't explain you thoroughly because at that time sudden visitors came. Actually, two of my friends. I have asked 50,000 loan from them to invest furniture to the institute. So they have come for that only. I had to quickly finish the class. So anyway, so let's say the forces F1, F2, F3, and this angle alpha, beta, and gamma. So then the Lamis theorem is we wrote. I'll erase this bottom part. So what we wrote Lamis theorem here. F1 over sine alpha. F1 over sine alpha is equals to F2 over sine beta. Sine beta is equals to F3 over sine gamma. So this is the Lamis theorem. So this Lamis theorem we can also construct in different way. We can represent in different way. We take the three forces. So if it's in equilibrium, we can construct a triangle. And this is, sorry, one should be downward. And F3. Now we want to mark the angle. So first I mark these forces F1, and this is F2, and this is F3. Okay. So we want to mark the angles. So yeah, hold on. Okay, what is the angle between F1 and F2? F1 and F2 we have. So I extend this line. So F1 and F2 between F1 and F2, that angle is gamma. So gamma, this angle is gamma. So F1, F2. Okay. So that angle is gamma. You can think if you extend this. So here you can see this angle is gamma. So vertically opposite, this angle will be gamma. Okay. And the angle between F2 and F3. Angle between F2 and F3 is alpha. So this angle is alpha. Okay. Alpha. And then I can write angle between F1 and F3. Angle between F1 and F3 is beta. Sorry, wrong. So here, F3 this one between F1 and F3 is beta. This angle is beta. Okay. So now here I take three angles. Let's say this angle is theta 1. Okay. This angle is theta 2. And this angle is theta 3. Okay. And then I write, consider this f1, and then opposite to this theta 2, f1 over sine theta 2, and then f2 over sine theta 3, sine theta 3 plus, sorry, equals to f3 over sine theta 3, sorry, sine theta 1. Opposite to this is theta 1, so theta 1, sine theta 1. So f1 over sine theta 2, this angle is this straight line 90 minus alpha. So sine 90 minus alpha is equals to 2 over sine theta 3 is 90 minus beta. 90 minus beta is equals to f3 is sine theta 1 90 minus gamma. Sine 90 minus, sorry, uh, sorry, straight line 180 minus sine theta 2 is 180 minus alpha. Theta 3 sine the 180 minus theta, and this is sine 180 minus gamma. Okay. Now, what is sine 180 minus? Let's say 180 minus x equals to what? Anyone? What is sine 180 minus x? If you simplify this, yeah, I'm expecting an answer. Okay, good. So here this one will be sine x. 180 minus angle means it's in the second quadrant, so it's plus. 180 means it's 19 to 2 even, so it won't change. Sine means sine, so sine x. So therefore here we get f1 over sine alpha equals, and then f2 over sine beta equals f3 over sine alpha. So therefore, the Lami's theorem you can apply either representation. I mean, maybe you can consider this and right, or you can consider like this and right. So whatever the angle goes here, the opposite to that is angle theta 2. So either ways, we can write the Lami's theorem. If anyone didn't understand, please raise your hand. I'll count 1 to 10. So if anyone didn't understand, raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I think everyone understood. Okay. All right. Okay, so we move on to the next one. Okay. answer to this question. We'll see who can get the correct answer. Aisha, good. Correct. Mm, Yash, that's not the answer. No, not that one as well. I think the final answer is correct, Yash. And Zufar correct. Abhiushani, that's not the answer. Okay, so two equal masses A and B are attached to a light inextensible string passing out smooth light fully as shown in the diagram. Okay, the mass B is moved downward. Okay, so two equal mass, both the mass are equal. If it's 1 kilogram, this 1 kilogram. The mass B is moved down, held it stationary, and then so initially like this, I move B downward and release. Which of the following statement is correct for the subsequent? So the answer is third one, B will stay stationary because since both sides have same masses, the same pull in both sides, so it will remain stationary. Okay. But if you give a small equal velocity, like for example, let's say 2 meters per second, so it will move with that same 2 meters per second speed. Okay. That's Newton's first law. The object remains at rest. Object at rest remains at rest. Or object in motion remains at constant velocity if no external forces, unbalanced forces applied. Since the forces are balanced, so B will uh, so it says held it stationary and released it. Okay. So if we give us velocity and release, like 2 meters per second velocity and release, then B will continue with the velocity of 2 meters per second. Okay. So the answer is B, it will remain stationary. Okay. So this question number 15, now you should be able to say the answer in seconds. Because we already discussed this type of question earlier. So you can understand doing past papers really helpful. So those who are attending 2001 past paper, if they have done this year past paper, this which year? 1996 past paper and then explanations and all study thorough. So for that person, can write the answer for this in a second. Yeah, Hiroshi, your answer is correct. About the others? Anela, we discussed such a question earlier, right? The 1996 question. It is similar to this. Aisha, correct. Yeah, Hirosh, good. Yeah, you can start doing past papers. You had to do by keeping time. Okay. So first you take the MCQ paper. Okay. So first you can write if you are taking printouts and taking the same question means fine. Or else you can put the numbers in a. I mean, if you are doing the answers in a book, then first you put the numbers 1 to 50, and then take the stopwatch timer, and then you can keep for 2 hours and do the past paper. Start doing the past papers. Okay. I recommend you to do the past papers from earliest year to the previous. Okay. Because මොකද්ද කිව්වනම් ඔයාගේ paper එක ගොඩාක් related වෙන්නේ to the previous years, not for the old papers. Okay. So now when you're doing past papers, you have to improve your doing past paper skill. Okay. එතකොට you have to, like, suppose if you sit the exam last year, then you have to see how much you will get, right? So for that you need to practice now. So therefore you have to take uh, the you have to do the past papers from earliest years to, I mean, in the chronological order. Okay. So for example, 2012, 13, 14, 15, 16, like that. Okay, then you can see an improvement. Now let's say, for example, if you did 2015 paper, you let's say you have covered only 80% of the syllabus, then you may able to answer only 45 questions or 42 questions. So 2015 paper, you answer to 42 questions. Out of that, 36 are correct. And then when you do 2016 paper, you can write you can write the answers for you write for 45 questions. Out of that, 38 are correct. So in the next year, so you can see that improvement there. So therefore, I recommend you to do the papers from the earliest to, I mean, the ascending order. Also, you must keep time. If possible, keep timing. The timing 2 hours. No, that means 120 minutes. So you keep timing for 110 minutes and do. So if you practice always, then the 10 minutes will be there for you in your order. It will help you. So keep timing 110 minutes and do. Okay. A weight W is hung on a tightly fixed rope as shown in the diagram. The tension in the rope is. So in the previous question here, I told you if the angle is this angle theta is approaching to 90 degrees, the value will be tension will be the required tension will be much higher, right? So therefore here the answer will be fifth one. Uh, the tension in the rope is much greater than W. Okay, because this angle you can see it's closer to 90 degrees. I mean, if you this angle, so this angle is closer to 90 degrees, therefore much greater than W. So 2001 year के exam करप के 96 paper एक discuss करला दिबाना. For that person there is nothing to think. When he read this question, okay, done, understood, move to the next question. Okay. Okay. Okay, so do question number 16. Can anyone got the answer? Okay, so here we want to find the reading of the spring balance. So the reading of this spring balance is actually the tension in the hook. So T for T. So R is actually equals to P, then we want to find P. Okay, so in order to find P, first I'm taking the moment about this point, say O, and O I take anti-clockwise movement because I want to find this normal reaction close here. Let's say that is so this reading I take as in. So here if I take the anti-clockwise movement, so this one's weight in 1G. So in 1G and R also anti-clockwise plus R. And then in 2G, the weight of this is anti-clockwise, sorry, clockwise. And the weight of this uniform of bar of mass M. So this mass on center midpoint, capital 2. But it won't come because no perpendicular distance. So this is equal to 0 since it's equal to 0. So R equals M2 minus M1 times G. Okay. So those who have good practice in such question, they won't write this anything. They will do the calculation. They know this R will be equals to M2 minus M1G. Okay. So even when I'm reading this, I can understand here R equals M2 minus M1G. Okay. Since because M2 is greater than M1 and it's hanging from the center, මේ පැත්තට M2G ගුණයක් ඇති කරනවා මේ පැත්තට the moment this side is M2G and this side M1G. So therefore, since this is large, the balanced one should be balanced by, I mean, the the difference moment should be balanced by R. So M2 minus M1 G should balance by R. Okay. So the difference in moment should be balanced by R. So therefore M2 minus M1 into G. R must be equals to that. Because here the length won't become because the length midpoint no, taking the moment. So the length will cancel. So therefore the R has to be M2 minus M1G. Okay. You have good practice. You won't even write anything. You can straight away think okay, R equals M2 minus M1G. So then the tension E equals to very simple. This equals to all the forces. Okay. So M1G plus M2G plus capital Mg minus R because R is acting upward. Or else here actually R plus T equals to this. We'll take the R to the other side. So it becomes minus R. So minus R means here minus M2G plus M1G. Okay. So if you are writing this, you may confuse. So I'm writing the next step. So P equals M1G plus M2G plus Mg minus M2 minus M1 times G. So if you simplify this, then we get P equals, so here M1 plus M1 to M1G minus M2 and minus M2 cancel plus Mg. So the answer is 4, 1, capital M plus 2M1G. Okay. Okay, so here similar type question. A bird of mass M6 on a tightly stretched telegraph wire shown in the figure. The additional tension produced by bird in the wire is. Okay. What is the answer? Yeah, super correct. Hirosh correct. Yeah, Ash and Abhishani. Aisha correct. So the answer is third one, more than inch. Okay. Do the 18th question. Yeah, three masses ABC are hanging from horizontal cross bars as shown in the figure. Each crossbar has negligible mass. If A has mass 6 kilogram, the mass of B and C respectively is 6 kilogram. The mass of B and C. Okay, Aisha, your answer is correct. Refer correct, Abhishani correct, yes. Okay, so here Mitchell. So A is 6 kilogram and it's in equilibrium. So the moment about this point should be same. So here the ratio 1 to 3. So the mass ratio should be 1 to 3. So therefore here the total mass should be 2 kilogram. So the total mass of B and C should be 2 kilogram. Okay. And then the ratio between the mass of B and C is here 1, here 3, 1 to 3. So then by considering that, we can't take, the sum has to be 2 kilogram. So this one, but mass ratio 1 to 1. No, this one, no. The total mass is exceeding 2. This one can be, no, this is also exceeding 2. So one of these two, and then you can see, so here 1 to 3 ratio. Second one is the correct answer. And these questions don't write or anything, okay? You should know here the 6 means 1 into 6. So here 3 into 2. So the total mass should be 2. So here 3, 1 to 3. So therefore here 3 to 1 should be 3. Okay, so the answer is 2 kilo. Second one, 1.5 kilogram and 0.5 kilogram. All right, so we'll conclude the class from this question. If you have any questions regarding today's discussions, you can let me know.